And now we turn to our final panel of the day, Advanced Technologies Broaden Aviation Security Challenges. This conversation will focus on, we all know that the aviation community of operations is growing with new technologies, both in the air and on the ground. And these stakeholders will discuss opportunities for sharing the requirements to maintain and improve our certainty that aviation remains safe and secure. Again, there is a tab on the bottom of the Zoom screen for Q&A. Please enter your questions there, and we'll try and get to them as quickly as possible, or to as many of them as possible. And now I would like to introduce Nikita Johnson-Needle, Product Cybersecurity at Rolls-Royce. Nikita will moderate our session. Thank you. Welcome to all of our panelists, and over to you, Nikita.
Thanks, Rebecca. As Rebecca said, I'm Nikita Johnson-Needle. I'm a product cybersecurity engineer at Rolls-Royce. I'm responsible for security capability deployment and a ISMS technical specialist. So I've completed a PhD in security assurance for safety critical systems, so very topical subjects today. And I now co-lead the subgroup in Working Group 72 SE 216 on the ED 203 FAQ document. So I would encourage participation in that. We need as many stakeholder input. So as we said, this panel will be more future-facing than the previous two panels, and I'll just let my panelists introduce themselves. So Greg, you're up first, please.
Thank you, Nikita, and thank you to the RTCA for the invitation today. We're looking forward to the opportunity. It was almost as if someone had strategically planned the previous topic. I really appreciate Mr. Windus's introduction to this panel, where we're going to touch on safety and regulation. So my background is as a Navy test pilot for P3s and P8 Poseidons more recently, and I currently am the Director of Cyber Warfare for Naval Aviation at Patuxent River Naval Air Station, where I work at Naval Air Systems Command Headquarters. That's where the U.S. Navy does all of its acquisition of its systems. So we do all naval aviation systems acquisition, and my role there is primarily as our cyber and system security engineering tech warrant holder in our implementation of technical authority for issuing airworthiness determinations for our aircraft.
Excellent. Thank you, Greg. Ben, you're up next.
Thank you. Cyber Ben. Usually that's all I say. That's just going to introduce myself. This time I will go in a little bit more detail. I actually did my master thesis with Timo Vance. He was my supervisor. He was in panel 2. That was on secure data loading. And afterwards, I've been basically being a consultant and traveling around the world for a while, doing avionics system testing, as well as working with airlines. And then I've spent some time with one of the eVTOL companies, Lilium, setting up basically the aircraft security engineering department and setting up all the processes and all the things around that. And afterwards, I basically started my own company, and now I consult in the area of engineering management, as well as going towards Part IS.
Excellent. Thank you, Ben. Mike.
Yeah, my name is Mike Van Gardy. I'm currently the Chief Architect with Boeing Commercial Airplanes Product Security. Kind of got my start working with the U.S. Air Force, primarily space and RF systems, but started to work quite a bit of cyber issues as part of that, and then have spent the last 20 years at Boeing. So really what my job is to make sure that we're looking at the secure design test from the whole ecosystem, from product design and ConOps to test validation and sustainment. So thanks for having me.
Excellent. Thank you. So whilst I really value the standards work that we do within SE 216 and Working Group 72, it's often reactive. So either to the regulations or to the current threat landscape and the threats that we're trying to address. For this panel, we have a really exciting opportunity to look into the future a bit. And we have 3 forward-facing goals. So the first is to identify key challenges and highlight practical solutions. The second is to generate some thought leadership around some of the core topics that we're going to be talking about. And then the last is to foster some cross-industry collaboration and discussions. So with that in mind, the 3 core topics we'll be discussing today are the aviation safety effects from cyber going into the future, aviation cyber technologies and engineering, And then lastly, future technologies, so autonomy and regulations. So Greg, if I could ask you to kick us off with aviation safety effects from cyber.
Yeah, absolutely, Nikita. So this is an interesting topic in a military context. It has a bit of a different bent to it. So an opportunity to discuss this today. I think what I'll do first is sort of set the table for those of you who may not be familiar with how we do aircraft certification on the military side. In following on to Phil's discussion with rules, we also have rules, of course, in the military that keep us aligned. And in this case, we use the MIL Handbook 516, which is a military handbook for the entire Department of Defense airworthiness certification process. And we use that at NavAir just like the other services do as well. And what that does is it allows us to follow our methods of compliance to establish a safe operating envelope for aircraft. It helps us to establish the safe operating procedures as well. We might find it interesting within the military context that we don't actually issue airworthiness certification for our aircraft at NavAir. We issue what we call an airworthiness determination, which is really a risk management decision for how the operational fleet will operate that aircraft safely. So safety obviously has a very strong context within airworthiness. We also have a number of mission systems that we operate that may not have a safety context to them. So we have to include all of those things inside of the architectural discussion of cyber. When we look at safety, it ties largely to a mobility mission. Can I get from point A to point B? In a military context, we've brought the term survivability to the discussion. Air combat survivability has been a term since the early 70s. And we execute that inside of a contested environment. So the idea being that our platforms are going to operate in some sort of a contested environment. The idea that cyber would be part of that contested environment is actually a relatively new context inside of the Department of Defense. In 2016, early 2017, we created what's called the Cyber Survivability Endorsement. And that includes a few areas of what we call cyber survivability attributes that we are looking to design into our platforms. And those largely fall within 4 categories: the prevention, mitigation, response, and adaptation to a cyber effect. So as we categorize our work, that's largely the way we do it. We decompose those down into derived requirements for our systems and then map those back to those survivability attributes. On the other hand, what we've been using as risk management for cyber in the Department of Defense has largely fallen within the NIST risk management framework, is the framework that we've largely implemented over time. What we've found is that the implementation of RMF outside of an engineering implementation really does not work, and it's not sufficient. So we're looking at ways of integrating all of our cyber work into systems engineering to ensure in a certified aircraft, we're actually answering that safety question. So at NavAir, for instance, we actually have never issued an airworthiness determination with what I would call a cyber technical authority or a cyber tech warrant review. And we are about to start doing that. So as the MIL Handbook 516 starts to consider bringing some of the RTCA DO 326, 356 standards that for security that Phil was mentioning, we're trying to get out in front of that and starting to implement that work into our architectures now. So that contested environment is on the military side. We tend to use language that's a little stronger than security when we talk about how we're going to operate in those contested environments. So it's a very interesting discussion that, first of all, the position, navigation, and timing discussion is first and foremost in my mind today for how we operate in a safe environment. And then we'll get into some of the further discussions with this panel in autonomy. So I'm looking forward to those. I'll stop there, Nikita. Thank you.
Excellent, thank you. So to lead us on into some of the questions, so we've seen an increase in convergence between product cybersecurity and influences like electronic warfare or financially motivated attacks with safety effect. So I'm just going to bring in Mike at this point. Do you have any comments on how going forward our organizations can tackle these kinds of convergences?
Right. I think TNT, to Greg's point, and again, it seems everybody's talking about position, navigation, and timing and GPS. But essentially, cyber didn't start out that way, right? It's traditionally, and I came from Department of Defense, working on military systems as well. It was really about the confidentiality, integrity, and availability of systems, mostly terrestrial type IT systems. But when you start to think about our aircraft are a system, right? They're truly a cyber physical system. There's command and control. If you can induce a safety event through cyber means, that's very, very concerning. And so what we're looking at right now is, again, we have special conditions for a long time, and we had certification review items from EASA. That's evolved now where we're getting true rules, and the new proposed rulemaking is starting to even point to, do we need to pull in GPS? Do we need to pull in aeronautical comm like ACARS under the definition of intentional electronic unauthorized interference? And I think, there's a lot of ramifications for that, because that truly gets into the more the sensor package and the safety side. And so we're right now as an industry trying to determine how to best handle this. We're not waiting for rules. We know there's potential issues right now. But our engineering centers and our avionic groups and nav radio teams, we're looking at a lot of these effects. And really it comes down to, can we trust the data? To kind of pull on a term that I hear from some of my DoD and our defense counterparts, some of these issues are kind of resulting in weaponized doubt. If you can't trust your avionics systems, right, that potentially can result in a safety effect. And so for us, again, we have to go research this. We really need to get better definition on is jamming in scope. Jamming is electronic, interference. Definitely, I can see spoofing. That's, the manipulation of the data. If you can't trust the data, most safety hazards I've been involved with, the loss of integrity of data tends to be a bigger safety hazard. So looking at that holistically, really integrating with our core safety office and our avionics teams is kind of where my group, the product security engineering, kind of sits in the middle of that. So I think we need to continue to look at this as a whole. This is not a Boeing problem. It's not an Airbus problem. It's not any one vendor's problem. It's an industry problem. And so these are just kind of the things we have to be able to pick up and pivot as new threats come into scope. We need to collectively work those threats. And again, there's no competitive business on safety. We need to kind of work it together and solve those challenges. So maybe I'll pause there and see if any of the folks have comments. So.
Thank you, Mike. Ben, do you have anything to add to the safety effects?
Yes. So basically, like, from my perspective, working more with the smaller companies and more like on the electrical side of things, it's nice that Timo in panel 2 showed like the interface landscape of an aircraft, like how it's connected and how it's communicating. And this is something where, like, from an electrification perspective, there's also these threats coming up when you talk about like charging of an electrical aircraft and how do you actually interface with an aircraft in that sense, because this potentially directly connects to a safety critical system. The batteries are basically part of the propulsion system. So you need to make sure that, like, from this perspective, you also consider that whenever you add new interfaces, whenever you like advance in your design and bring up new technologies, that like from security, you add new attack surfaces to your system potentially. And this is one really interesting example because there's adoptions from the automotive industry. They have done certain things. You also know that there has been certain vulnerabilities in like the charging environment for automotive. So that's also something where you can learn from, but you also have to see it in a different perspective that like an aircraft is flying in the sky. You can't just stop on the side of the road and like try to fix your car. It's like, it comes down if it doesn't have propulsion anymore. So that's just like a small twist to like the CNS and PNT discussion, that there's also like this new things coming up.
Excellent, thank you, Ben. So Greg, back to you. What do you think are the biggest gaps moving forward, and what can we do about them?
So I think, Nikita, first of all, the discussion so far speaks to the architectures that we're using inside of our platforms and how we establish segmentation and how we account for what I would call an evolving threat model. We've seen a lot of different evolving threats over the last few years, a lot of which have to do with the changes in microelectronics, the availability of software-defined radios, and frankly, the ease by which systems can be manipulated by an external actor. So, those interfaces externally, I like to tell my team, anytime you have an unauthenticated and unencrypted interface into your platform, you need to look hard there to see how that system is interacting. So, we start there at the external parts of that architecture. My concern largely in my portfolio is with connectivity. And I think Ben just referenced this, we start to connect things and suddenly you have access from a lot of different means. And those architectures become global very quickly in the interfaces. So those are big concerns for me. When I get into the engineering work that we do and how I'm looking to expand the assessment capabilities of my teams, we're looking at the supply chain hard. So the supply chain is definitely a concern, both from a hardware and software perspective for our platforms. The other piece is software assurance and software security. The implementation of that, we do a very good job of executing what I would call software reliability testing in safety critical systems. However, the software security, in my observation, has been lacking. So that's a place where we really have to start looking harder at, and I do that primarily today by execution of projects through my red team. I think it's critical that we bring technically talented teams into this operational technology space and let them red team our products. Over.
Excellent. Thank you, Greg. And that is a perfect segue into our next topic, which is aviation, cyber technologies and engineering. So Ben, we've been talking a lot about engineering cyber-safe aviation systems. So what role do some of these new technologies play in implementing some of these safe architectures that we've been talking about?
Yeah, so thank you, Nikita. And thank you, Greg, also for the brief introduction at the end of your points you made. So basically, like following up on panel 2, where we have seen the processes, how we actually do security engineering within aviation, like it's barely been talked about or barely been mentioned actually, how do you actually implement these processes? How do you actually make sure that these processes fit within like the whole design life cycle of the aircraft? How do you actually integrate it with safety and with assurance? So basically what I'm gonna point out a little bit is like how like the new and upcoming and small companies actually have a little bit of an advantage in terms of implementing a whole design organization, because they set up the whole design organization from scratch. So basically, there's no legacy engineering activities when it comes to how to design aircraft, how to do the safety activities, how to do structural stuff. So there's a lot of advantages into utilizing new technology, new software to actually make these engineering activities more streamlined and more aligned across the whole company. So basically, like just to give a little bit of insights on that, like when you like talk about the V model and like you design an aircraft, you do basic initial requirements, you go into like detailed design, you go into software engineering, hardware engineering. Everywhere there's like points where you can utilize tools to actually make your processes more streamlined and more aligned when it comes to working together with safety and working together with the other design teams. So just to give you a few examples, when we talk about requirements engineering, you don't want to have basically doing all the requirements for the whole aircraft from one engineering domain first, and then you give it to security and tell them like, look, this is what we've come up with for our aircraft. This is what we do. Do we have some inputs from security? So traditionally, this is kind of like what's happening in most companies still nowadays, but this is not how it should be done, because you're having like a loop going into security and then you're feeding it back into the safety or into the engineering aspect. So the tools actually allow you to make it more streamlined and actually to help you to implement these things. But also it helps actually to give awareness to the engineering teams to actually make sure that when you're having like the new topic of security engineering, which is still quite new for most companies, that actually also the other engineering departments have better insights on actually what has to be done from security perspective, what actually needs to be done from security perspective, and actually what are the security requirements we're having. So you're giving like more insights, and you're like having a more aligned activities, and then it's much easier to actually do security. So I mean, being tool agnostic, like how we should be. Like I'm not going to mention any tools which are out there, but there's definitely like much to learn from these new companies to have the advantage to actually say, look, we are implementing we are developing new aircraft from scratch, but we are also using tools which you probably haven't heard about before. We have just developed it in-house to actually make it much easier. This is like from an engineering perspective, that's obviously quite useful, but also when it comes then to how to actually do testing. A lot of security testing nowadays is also being done quite late, and you can also utilize more security tools to actually automate the testing, do vulnerability scannings on your code, like do basic static code analysis on the software you're developing. You can align it with your supply chain, so you can test the software you're getting from your supply chain. These are all things like where you can do a lot of automation, and even though it doesn't give you the full picture of like what you have to do, it gives you potentially necessary insights to actually change your design, make improvements, and give like the whole workflow is just much better afterwards. And another thing I want to point out is when it comes to the skills of the engineering departments. So like I mentioned before, like it helps also like to advance the skills of the engineers. So like panel 1, I think discussed, Olivia asked like how to actually get into the industry and how to actually start working within the aviation cyber world. If you actually utilize the tools to actually make it more transparent to the engineering, it's actually much easier to understand what actually are the challenges of safety, what are challenges of security. Like from my background, I mean, I've basically studied avionics as well as information security. So I kind of come from both worlds from the beginning of my career. For me, it's kind of like I easily understand the safety engineers and I also understand the security. But for a lot of like engineers in the industry, it's sometimes really challenging to actually get the idea of the different perspective. Like cybersecurity is like we intentionally want to break a system, we intentionally want to harm the aircraft or whatever is connected to the aircraft. So this is kind of viewpoint on like how to actually enable that. Like tooling can actually really help to actually make this more transparent. And as a last point, when it then comes to like the operational perspective of the aircraft, you can also utilize these tooling later on to actually have much quicker insights on like what potential vulnerabilities you might have to actually investigate it in the scope of your environment. Like how can this potential vulnerability actually affect our safety of the aircraft? So having a more integrated toolchain, engineering toolchain, this also like in the operational perspective gives you the advantage to actually be quicker on like how to actually say this is like a safety impact or this is no safety impact. And as we know within the aviation industry, sometimes the safety processes are quite slow. So like it takes months or years to actually fix a system. So from security perspective, you want to be faster, and this tooling can actually help you in that sense as well.
Excellent. Thank you, Ben. And you've answered David Jones's question on where can you get the cybersecurity skills that you would need for the development. Mike, I'd like to bring you in at this point. So we've got a question in the chat about, do we ever draw the line for connectivity with aircraft? So Ben was just mentioning all of the great benefits we have, the insights we can get from operational data, but obviously that increases our attack surface and the types of threats that we're looking at. So to answer that question, should we ever draw the line and put a limit on how much connectivity our systems have?
Yeah, that's an interesting question. So, I mean, the aviation industry is long and slow, right? Our life cycles are 30 years. We very rarely have clean sheet design, right? We have to integrate new things with old things pretty much all the time. But for connectivity, there's reasons why you want to do certain things. There's no shortage of business cases on what, a fast broadband connection would do for certain design centers or design features. But to your point, yeah, I think we do have to be very careful on what we couple and what we don't, and potentially have different demarcation points or different almost, well, we know the connectivity domain. If you're familiar with the aviation industry, the ARINC 664 Part 7 kind of describes these connectivity domains. The problem with that domain model is that we tend to now have systems that talk to many different domains. So there's not a clear kind of boundary in some regards. But again, going back to the question, yeah, I think we have to understand the threats and the risks, and so that should be informed by threat analysis, risk assessments, and ultimately the safety hazards that are associated with that. So while I'm a proponent of not just saying no. Like our job is not to, as cyber engineers, is not to say no. It's say how can we mitigate the risk and enable the business, the mission, the goals of the company. And so doing that is got to be founded in engineering data. So kind of tying this back to what the previous discussion was, is we need robust, engineering. You don't just do cyber at the end. What product security is was really what we used to call system security engineering. It was a sub-discipline of systems engineering. Ben kind of talked about the engineering V, how you would do upfront on the front end, you do ConOps and requirements. You start to do your design, and on the right hand of the V, you'll do your verification, validation, and certification. What we really need to do to understand what are our threats, whether they're connectivity, whether they're software, whether it's supply chain, is start to leverage some of the tooling, some of the newer tools. Ben also mentioned that, there's these new entrants that are bringing in new tooling, software tools. I think for Boeing, we're really all in on digital engineering, model-based systems engineering, really modeling what the system and interactions of that system and what some of the failures are, whether they're intentional or just based on failure modes, and leveraging that to kind of help us shift left. So again, I've as an ex-software engineer, I grew up in slow waterfall methodology where you took 3 years to do requirements, another 3 years to do design. And by the time you filled your system, it's already obsolete. So we need to move faster. We need to leverage those tooling. Right now, we do have, we're mocking up being able to run real avionics code in a simulation environment. That allows us to kind of inspect that software way earlier than we would, if you waited for the hardware to be ready and install it that way. We do a lot of penetration testing and injection, and just to try to introduce failure early on, so that while the system or software is still being developed, we have an opportunity to fix it. Doesn't really help us if we find issues at the end, because that's very disruptive and it really delays schedule and cost, increased costs. So again, using those tools, understanding the risks, allows us to move a little bit faster. And ultimately, that's what this industry needs to do. We need to keep iterating, again, with new things and old things, just understand the risk and what we can used to call, find, fix, find issues, fix those issues, and find them again. So it kind of goes back to always looking at the system, leveraging those tools, and trying to basically design out those risks before we get to the finished product line. So.
Excellent, thank you. Greg, what challenges do you foresee in trying to balance some of the goals that we want during operation and cybersecurity engineering?
Yeah, so a full list of challenges, Nikita. There's certainly a number of them. I want to foot stomp a couple of things that I heard Ben and Mike say. Regardless of the technology, it's the people and the talented workforce to be able to do this type of work, system security engineering in an aviation context. They are a bit of a unicorn. So finding those talented people to work in these environments is critically important. I would say it's more important than the implementation of the technology. The technology is going to drive us, and we are always, regardless of what we say in terms of connectivity and how much it helps. I think that I know in my portfolio, the signal demand for capability is always going to outdrive security to some aspect, right? It's always going to be running out in front, and we're going to be playing catch up with trying to lay in security behind. So the other piece of what Mike was talking about in this idea of testing left and getting left of the engineering implementation, testing earlier, validating and working. When I talk to my engineers about this, I really, those who aren't as familiar with the cybersecurity side of this work, I tell them this is really about configuration management of your system. If you think of it that way, I need a strong security configuration, and a system security engineer can help you establish that. So a lot of that work, I think, is critically important. For one part, in Department of Defense engineering, I have the advantage this week of being at the Aviation Cyber Initiative Cyber Rodeo in Huntsville, Alabama, where we're talking with the Army Test Center here about how they are implementing modular open systems architecture. So the MOSA implementation into our aircraft systems is a given now, right? We're actually being directed by US law to do that. And as we start to implement that, if you put that alongside of the risk equation, which is a combination of threat, vulnerability and impact, you look at the advantages of an open system architecture that we're being driven to, and those advantages actually increase the threat and increase the impact that an adversary could have on your system inside of a MOSA environment. So that kind of forces us to center in on the vulnerability aspect. So where are the vulnerabilities in my system, and how do I reduce those? Because I'm really leaving the door open with higher connectivity in these open architectures for the other two risk inputs to drive wild. So that focuses me back on my supply chain, back on my hardware and software vulnerability analysis and vulnerability management there. Again, the adversarial assessments that we do through our red teaming. That's early test and evaluation, which might be penetration testing initially, and then turning into a full adversarial assessment on the platform. So I think that's our challenge in the new and upcoming architectures that we're building, is how do we manage those vulnerabilities inside of the system in a new environment that technology is driving very quickly. Over.
Thank you. And I think that leads us nicely into the last bit of our discussion. So Mike, what do you think is the most disruptive technology, maybe referencing autonomy and some of the regulation changes we're seeing from a cyber perspective, and how do our organizations adapt to stay ahead?
Yeah, I guess the big elephant in the room is, again, you kind of talked autonomy, and really what's behind autonomy is AI. But if I pull that back into the context of what's new for aviation, it's really this growth of, or planned growth of, urban air mobility, advanced air mobility, what we call remotely piloted aircraft systems. All of that's all new. Right now, if you really start to look holistically at aviation, I think that's probably one of the biggest disruptors, like the NAS, the National Airspace Air Traffic Management. We have already saturation of flight paths, right? If you've seen how many flights are given in a given day, and we have to manage all of that, right, through our air navigation service providers and civil aviation authorities. Now you add, X number, 50,000, 100,000, million more things flying around that we have to understand. And guess what? They might not have a pilot in the loop. And so those kind of things, and how do you design a system? Like, the biggest control that we have in civil aviation is we have two pilots, right? And when everything else goes sideways and haywire, we know that we have a human in the loop, and we have two humans in the loop, right? To kind of protect us, and as that kind of last fail safe. And so that's kind of the big push is when we have autonomy, can we get down to one pilot aircraft? When we think about, again, autonomous vehicle, how do we know that we can control that? I guess kind of tying this back to some of the other big, so you thought Commass surveillance wasn't important? For a piloted aircraft, going to collide or cause a hazard with another vehicle, aircraft, or people. So putting that all together is really, to me, is probably the thing we need to focus on the most. The FAA has introduced something called the InfoCentric NAS. They have a ConOps and that kind of talks about all these new entrants. The other thing in there is space, right? We are now at the verge of space used to be privatized. It used to be defense only. Now we have reusable space vehicles in all this commercial and civil space. All of these things are competing for the resources for kind of managing the national airspace. And we just got to make sure that, again, those systems are architected securely. Again, kind of going back to AI, the other thing on there is you kind of have two pieces to that. You have the AI that you're going to use as part of that autonomous function. Definitely need to understand that better. I think that's a challenge right now within our regulatory and airworthiness environment. How do you certify that, right? When we do certification and tool qualification, we need deterministic data, and you don't quite have that in some cases when you're thinking autonomy. And on the flip side of that is the AI of how can we leverage that, right, to help us design the systems. Again, Boeing has kind of embraced some of the AI. We just recently had our internal first ever AI kind of summit to kind of talk about some of the risk and where we could go with that. Several years ago at DEF CON, there was something called the DARPA Grand Cyber Challenge. And really, that was kind of the first thing I ever saw about weaponizing, in some degrees, automation, right? They didn't really call it AI yet, but basically automated systems that were going to basically, without human in the loop, go find flaws in a system in itself, patch its own self, and go attack another system. And I think that's where you're going to kind of see, and we're already seeing it, right? The bad actors, the threat actors, the nation states are leveraging those tools to do harm. So we need to be ahead of that. We need to leverage that as best we can in our design and stress test our systems. But again, I think some of those areas, again, are some of the things that keep me worried and where we really need to get people smart really fast. So I'll pause there. Thank you.
Excellent. Thank you, Mike. So something very interesting you mentioned is our regulatory landscape and what we do to demonstrate that these systems are both safe and secure. So Ben, in our FAQ work, we know that ED203A is not good at characterizing the credit we can get from ground support systems. But from Mike's answer, we know that a lot of the security credits that we need for these new technologies will be from ground support systems. How do you see those two coming together over the next 5 years?
So I think it's a challenging topic because I think we start to put certain trust into systems which are on the ground. So right now, like Greg mentioned it before, like the aircraft is kind of like it's isolated. It's flying there, like we can barely touch it, but now we get like the connectivity into it, and we're also getting like with the advanced air mobilities VTOL, we get like reduced aircraft architecture. So like the aircraft architecture is much simpler, which gives you the challenge that like securing it, it's also like you have to have a different approach to that. So I think over the next years, like not necessarily for the large aircraft, which like I think like ED222 or 3, they are more like focused on large aircraft, but like the next 5 years we have to focus also like on how to actually adopt these standards for like smaller aircraft, VTOL, more connected aircraft, to actually make sure that like we as the industry can make sure that like we keep it as secure as we are right now, and that like even they are more connected, that we have like the same level of trust basically towards these kind of aircraft and technologies as we have to our large aircraft. Again, and that's obviously a challenge, but it's something we have to work on, and we have to like proactively work on, because it's aviation, and like we live from the trust we have.
Excellent. Thank you, Ben. Greg, I see you nodding your head. So we've got a question from Regina Harrison in the chat. The core of the question is, do we see any additional security add-ons? I'm going to extend it to these technologies, not just AAM and air taxis. So in particular, do you see any additional need for radio frequency spectrum or other technologies in order to make these systems more secure and therefore more safe?
Yeah, we always need more spectrum, right? I don't know that we can ever have enough, and then right when we don't have enough, we sell some off. So it's been a challenging aspect of that. We touched on this briefly earlier. We've titled this topic EW and cyber convergence inside of NavAir, and we've talked about this for a little over a decade now, and actually have seen some of those things start to converge. It's similar to an answer I would have given to your earlier question of challenges in technology, and you asked Mike, what is the what do we think is really at the head of this in terms of technology, most disruptive? And it starts to be a combination of these things, right? When you start to look at what's happening in space, the software-defined radio and AI, and you start to layer those things together and see what capabilities are possible, that becomes very disruptive very quickly. So I think our challenge is to be able to meet those upcoming threats, understand what they are, and be able to design against them. And we have to be clear that we're designing against what we know in terms of the threat models that exist. Over.
Excellent, thank you. So I'll just bring it back to you, Mike, for closing this last discussion topic up. Is there anything more you can add for these future technologies and how we can stay ahead?
I guess the one thing I'll say is there's a lot of work, right? There's no shortage of work in doing this, the design and certification and compliance finding of aircraft. What we need, though, is we need more. To me, we need more people. This is a very niche. I think we stated that before. It's one thing to have cyber or system engineering skills. It's another to overlay that within the aviation construct, right? And then even more then is knowing some of the new technologies. And so getting more people involved. I think some of this can be helped with academia, finding those programs, developing new programs to get people smart right out of the gates. Right now, we have to grow our folks. I've never found, and I was one of them, right? I wasn't an airplane cyber person. I was a RF space systems guy. I had to learn cyber along the way, but we've had folks that are cyber that had to learn aircraft systems and other kind of systems engineering functions as well. So we need more people. We need to have the right kind of skills and training, and we need to kind of grow that ourselves. So maybe I'll leave it there. Thank you.
Excellent. Thank you very much. I think we're coming up to time. So just a brief recap. In this panel discussion, we've covered the safety effects from cyber. We've covered some of the new technologies we can use for developing cyber safe applications in both engineering and in the architecture. And we've had a brief discussion on sort of the forward-facing challenges and how to address those, like autonomy and regulations. So, Rebecca, I don't know if you're online and if I'm handing back to you.
Thank you. Actually, handing back to me.
Okay, brilliant.
So thanks to all the panelists, to Nikita Johnson Needle from Rolls-Royce, Mike van Grada from Boeing, Greg Sleepy from US Navy, and Dane Nagel from Cyberben. So as for other sessions, the recording will be available shortly in the event lobby, as well as on YouTube, so feel free to revisit the discussion and share them with your colleagues. For those interested by the PowerPoint, please reach out to a membership at rtca.org, and we'll make sure you receive them. Also, don't forget to check out our pre-recorded on-demand session on a range of related topics.